All right, so let's talk about resistance formulas. Before I get into this, I want to make sure you are clear on the idea of equivalent resistance. If I talk about total resistance or equivalent resistance, what I'm basically saying is what I want to imagine what would happen if we got rid of the multiple resistors and replaced them with one. How much resistance would that one resistor have to have in order for the rest of the circuit to still behave basically the same way? So you can see in problem A right here, I have a 10 ohm resistor and a 5 ohm resistor. So if I'm talking about equivalent resistance, I want to know how much is their combined resistance. If I pulled them out and plugged a new one in, what resistor would I have to put there to have it behave in the same way? Series circuits and parallel circuits will have different formulas that give us the equivalent resistance. For a series resistor, on your formula sheet, the equation looks like this. Uh, Basically, it says it's the sum of all of the resistors. So a better way to write this, and how they honestly should have written it, is they should have just done it's like R1 plus R2 plus all the other ones plus whatever number of resistors you have. You just add them all together. And that's the equivalent resistor if every single resistor is in series. So right here, I have resistor A plus resistor B. That's 10 ohms plus 5 ohms. So my equivalent resistance is 15 ohms. Cool. We know how to do that. The next problem, problem B, is pretty similar. Because they're all in series, I can just say that the total resistance is going to be equal to R1 plus R2 plus R3. The only thing that's different here is instead of solving for the equivalent resistance, I've been given the equivalent resistance, and I'm trying to figure out what the third resistor is. Since I know the equivalent resistance is 24, and this is 1, and this is 2, this is basically just a very simple arithmetic problem, and R3 must have an equivalent resistance of 21, and I'm 90% sure that's the answer, but I did just say it was a super easy problem, and I hope I didn't just make some dumb math error that you guys are all going to make fun of me for. But I'm pretty sure 24 minus 1 minus 2 is 21, so I think I'm good. All right, in parallel, let me change color so that it pops a little bit more. The parallel formula is much worse. The parallel resistance, 1 over Rp equals the sum of 1 over Ri of all of the resistors, or written out 1 over R1 plus 1 over R2 plus 1 over R3, and so on. Now, I want to warn you guys, this isn't just a really complicated way of writing the thing that was in blue. This will give us very different results, and you have to make sure that you use the equation and you don't take shortcuts, because the shortcuts aren't going to work. So let's do problem number C right here. And I'll show you guys the right way, and then I'll show you why just like trying to cheat wouldn't work. So the equivalent resistance here, 1 over Rp, is going to be equal to 1 over 4, because that's my first resistor, plus 1 over 12, because that's my second resistor. Basically what I just did is I did 1 over Rp equals 1 over R1 and 1 over R2. And I plugged in the 4 and the 12 because that was the resistance of each resistor. So if I add those together, 1/4 plus 1/12 would be the same thing as 1/4 plus, 3/12 plus 1/12. So that's 4/12 equals 1 over Rp. And so I always draw it like this. I always do this at the end. I just, like, you have to flip it over before you're done. I want Rp. I don't want 1 over Rp. So I have to find the reciprocal. So it's going to be 12 over 4, or 3 ohms is the equivalent resistance there. So a 4 ohm and 12 ohm in parallel actually has an equivalent resistance of 3 ohms, which is less than either one of the resistors was separately. In parallel, adding more resistors will always end up with an equivalent resistor that's less than any of the resistors that are in there. Basically, what's happening there is we're giving more paths that the current can flow down, which will always decrease the total resistance. All right, let's do this one other problem. I have 4 resistors. Let's call this R1, R2, R3, and R4. So I'm going to have 1 over Rp equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. And that's going to end up being, let's see, 1 over 2 plus 1 over 4 plus 1 over 4 plus 1 over 1. Let's see, 1/4 plus 1/4 is 1/2. I have 2 halves, that's 1. That's 1 and 1. So that adds up to a total of 2. But remember, you have to flip it over when you're done. Don't forget with your parallel circuits, you always have to flip the resistance at the end. So my equivalent resistance 1 over RP equals 2, which means really the equivalent resistance of all of these parallel resistors is half an ohm. So that's how you do resistance formulas. We will be practicing this, but make sure that you know these formulas. And pretty importantly, you know how to find them on the formula sheet and use them on the formula sheet. All of our electrical formulas are along this side. Everything else we've done this school year has been here. We now have a little box that all of our electricity stuff is going to be in, with a couple constants for electricity there on the back side. That is the resistance formulas. Thank you so much for watching, and I will see you guys in class.